Hi, this is Kenny Lee again, and this is our second installment of force table. In this one, we're going to have non-right angle vectors. So we're going to use the same equipment as last time. Here's the force table, our coordinate system. I'll raise up to 0, 90, 180, 270 because we're using forces. And the same spring scales that, again, measure from 0 to about 20 newtons. But this time we're going to set them up so there are no right angles between these three vectors. I want to set one of them here roughly at 0. We'll see what it turns out later. And then I want to pull the others just so long as we're not at right angles to each other, we're fine. So I want to stick this one up here. And I want to pull this one down here someplace. And let me flip this over so it can be read. And put that in the center of our crosshairs, or as close as I can come. Let's try to get this closer to 0. Again, let me twist this. There we go. That's not quite, but I can move this around just a little bit to hopefully make it at 0. And I don't look like I have any right angles between those. So we're going to call that good for right there. For this one, I'll mark underneath just to kind of spot check. And this one has a force of about 9 newtons. And we'll call that F1. This one I'll mark again underneath so we can get that measurement later. And this one seems to be at about, so that's 10, 11, 12, looks like possibly 13.5 newtons for F2. And this will be my equilibrant. And so its force looks like about, again, somewhere a little bit over 13. Let's call it 13.7. It seems to be a little bit more than the other one. And we'll mark under it just to kind of check on the angle. All right, I want to pull this out from underneath there so we can look at it. So this one we pretty much had at 0. I don't see a green line outside that. This one looks like the red was right at an angle of 110 degrees for that one. And our blue, which is our equilibrant, is between 240 and 250. So let's call it 245. So the angle for our equilibrant is 245 degrees. All right, let's transition this over onto a worksheet so we can start figuring out if, first, the resultant, and then from the resultant, calculate the equilibrant and see if it matches what we actually got on the table. So switching between these, move that out of the way, and bring in our sheet. Okay, so at force of 9 newtons at 0 degrees for F1. F2 looks like it's around 13.5 newtons at 110 degrees. And our equilibrant, so around 13.7 estimation newtons at 245 degrees. So what we need to do is a process known as resolution of components, where we had one force at 0 degrees, that was 9 newtons, and another force, at 110 degrees, and that's 13.5. And so the resultant would be somewhere over here. We don't know. But what we need to draw is more of a vector diagram rather than an actual picture. So for a vector diagram, I want to draw the first force, 9 newtons, and then where that ends, draw in the second one. So this is again 110 degrees. That's 13.5 newtons. And our resultant vector should be from one to the other. Now this is not drawn to scale, so that's not a right angle. We don't actually know what that angle is. We have to actually calculate it. So using resolution of components, what you can do is set up a table so that you have your forces in the X and the forces in the Y, and you can set them up. So for like F1, we had 9 newtons along the X direction and 0 newtons in the Y. Now for F2, one thing that you can do is this. We've got this picture here. That's nice. From this picture, we've got so much of this vector is acting horizontally, its force in the X, and so much is acting vertical, its force in the Y. And so if we know this angle, then we also know this one. You can use either one actually, depending on how clever you are with your trigonometry. Now, one thing I want to warn you about is since this vector is over here in the second quadrant, the X value should be negative, but the Y value should still be positive. Then you can add those together, draw your new triangle, find the hypotenuse and the angle there, and that should be your resultant and your resultant angle. Then to get the equilibrant will again be the same force, so they should be equal to each other. But the angle we should add 180 degrees to, and see if it matches the equilibrant force that we got from the table. Try that calculation, see what you get. Maybe try percent error and come up with any sources of error that could have came about by watching me do the lab. Where could I have gone wrong? Thank you. Have some fun with vectors, and I will talk to you again later. Bye.